In this lesson, we'll just keep practicing more of the same strategies using slope and area to find position, velocity, and acceleration. So let's start with this question. Here we're going to find distance and acceleration given velocity. Every time we move up a level using area, we have to have an initial value given to us. So here we have this will be position, velocity, and acceleration. So let's just look at what we have. And we'll just start finding the desired values. We have 0, 1, 2, 3, 4. Alright, we know the velocities. Velocities are 0, 3, 4, 3, 0. 0, 3, 4, 3, 0. And from there, let's go to position. There's less guesswork in the position. We don't have to guess points on a line. We just find the area. Since we're moving up a level, we'll find area. And we know that the initial position is -2, and that was given in the question. So then we'll have -2 plus, now we have to find the area from 0 to 1. Well, that's a curved line, but we're just going to approximate it using a straight line. So now we just have a triangle like before, 1/2 base times height. And that'll be 3/2 minus 2, and we get -1/2. Then we have -1/2 plus, let's find the area of the next region. Just say that's straight and we'll make a trapezoid. So it's 3 plus 4 over 1. We have a -1/2. 3 plus 4 over 1 times, 3 plus 4 over 2. We find the mean of 3 and 4, that's 3 plus 4 over 2, times the base, which is 1. 7 over 2 minus 1 over 2 is 6 over 2, 7 over 2, and we get 3. So now we have a position of 3. We're going to add the next region. And the next region is just going to be the same. It's symmetric, so we have 3 plus 4 over 2 times 1, and that's going to be 7 over 2 plus 3, 6.5. Now we have 6.5 plus this last region, make it a triangle, 1/2 base times the height is 3. 3/2, that'll give us 8. So we have points for the position graph. 8, 4, and we'll have, at 0, we're at -2. At 1, we go to 1/2. That's 2, so 1/2 is going to be there. At 2, we're at 3. At 2, we go to 3. At 3, 6.5, and then 8. And that's in seconds, and that's in feet. Alright, and then we have to find the slopes of the tangent lines. Let's go ahead and find the slope here. What would the slope be? Just so that we have a place to go on the graph, even though we'll use an open circle because at the end point the slope is undefined. So let's draw, if that's a curved line, we're going to have a tangent line that looks like it might go to, if I draw that tangent line, looks like it hits, or it might hit 1, 4. So now we have this point and that point. So that'll be the slope at 0 is rise 4 minus 0 over 1 minus 0. We get 4. Then we're going to draw a tangent line at this point, and it looks like it might go through that point there. So now we have this point, which is 0, 3/2. We have to pick 2 points. So there's a point at 1, 3, and there's a point at 0, 3/2. I'm estimating this point. I don't know if it really goes through that point, but it allows us to estimate a slope. So that'll be 3 minus 3/2 over 1 minus 0. Then this is an easy one. We are going to use this a lot in calculus. Here's a horizontal tangent line, and we know that that slope is 0. Then, since it's symmetric, we can draw tangent lines, but we know that they're going to be just the negative of whatever's over there. So if that's a 1/2, we have a negative, that's a 1.5, negative 1.5. And here, if we drew that tangent line, negative 4. So let's plot those points. Seconds, and this is feet per second squared. So the endpoints will have an undefined slope, even though we know it's going towards 4. So at 0, we'll go to 4. 0, 4. At 1, go to 1.5. At 1, go to 1.5. 2 is 0. 3 is negative 1.5. 4 is negative 4, open circle. We'll get a graph like that. This will be 8, 4. We'll start here and here. And this is a velocity graph, feet per second. seconds. The initial position is -3, and find acceleration and position. Alright, pause the video and try that one. So here we're going to have position, velocity, acceleration, and let's draw the velocity graph. We need to find, or we have time, velocity, and then let's find position. Alright, velocity at 0, we're going to ignore that and just go here. Velocity is 0. At 1, velocity is 0. At 2, velocity is 6. 3, velocity is 8, 6, 0. And position is, we'll find position using area. We have the initial position of -3, and then we have to have -3 plus some area. So we'll look at this area and just approximate it with a triangle. So we have 1/2 base times height is 6. And we get 0. Then we'll have 0 plus, let's find this trapezoid, and that'll be 6 plus 8 over 2 times the base is 1. So it's 7. 7 plus, now we have this trapezoid, and that is going to give us the same value. It's the same here, 7, so we have 14. Now we do 14 plus, we need this triangle, which is going to be the same as these triangles are equal, congruent, so we have the same area and we get 3. 17. We can plot those points. And let's count by 2. 2, 4, 6, 8, 10, 12, 14, 16. And we have -2, -4. So this will be 16, -4. At 1, we'll be at -3. At 2, we go to 0. At 3, we go to 7. 3, 2, 4, 6, 7. At 4, we go to 14. And at 5, it's 17. Okay, and then we'll find slopes. So let's estimate the slope at this point. It looks like it might go through this point. So if we draw that tangent line, maybe it goes through 210. And now we have a point on the tangent line. We'll find the slope. We'll estimate the slope of the graph. We'll estimate the slope of the tangent line by saying that this point is at 210, and we're just estimating that. 10 minus 0. So this is the slope at 1. 10 minus 0 over 2 minus 1. And that would give us 10. Then we'll estimate the slope here. It looks like this might go through the origin. We can estimate that slope using this point and the origin. So that's going to be 6 minus 0 over 2 minus 0. 3. Then we get the easy one, the horizontal tangent line, slope is 0. And then these are symmetric. So we have this is the negative slope of that, and then this is the negative slope of that. So we can just make these numbers negative. And now we have points for the acceleration graph. And we have at 1, the slope is undefined, but we know it's going to 10. It's approaching 10, so we'll have open circle at 1, that's 10, and then negative 10. This is in feet per second squared, seconds. At 2, we'll go to 3. 2 goes to 3. 3 is at 0. 4 is at negative 3. 5 is at negative 10 with an open circle. All right, and when we learn more about calculus, we'll know that this line should have been straight, but since we approximated the slopes on the graph, we're not getting a straight line. Not distance, we'll keep calling it position. We go 1, 2, and 2, 4. Alright, so here we're starting with acceleration and moving up 2 levels. That means we're going to just find area twice. So pause the video and try that one. And we're starting all the way down at acceleration. So let's look at time, acceleration, velocity, position. Acceleration are just the y values of this graph, so 0, 2, 4, 4, 4, 2, 0. And velocity. We have the initial velocity is 1 at time 0, and that was given in the question. Then we have 1 plus, and let's find the area here, which is 1/2 base times height. So we have 2. Then we'll go 2 plus, find the area of the trapezoid, and this is 2 plus 4 over 2 times the base is 1, and that'll be 3 plus 2 is 5. Then we have 5 plus, let's just jump over to 4. We can, yeah, we'll go along this way. So we'll go at 3, the height is 4, and that's just a rectangle, 1 times 4. And then we have 9 plus, there's another rectangle, so that's going to be 4. Then we have the same trapezoid as we had over there, and that had an area of 3, so it'll be 13 plus 3, 16, 16 plus 1, 17. Then we can draw the velocity graph. We'll find the area of the velocity graph, and that'll give us the position graph. Zero, 1. And then we'll go 1, 2, 2, 5, 3, 9, 4, 13, 5, 16, and 6, 17. Now we just have to find the areas here, and let's just write down that this is a 2, 5, 9, 13, 16, 17 to help us find the areas using triangles, trapezoids. We need the initial position is 2. So we know we're starting at 2. And Then we're going to find the areas here. That's going to be 1 plus 2 divided by 2. So 1 plus 2 divided by 2 times the base is 1. That's a trapezoid, so we have the two heights. Take the mean of the two heights, 3 over 2 plus 2, and we get 3.5, 3.5 plus, and now we find this trapezoid, 2 plus 5 over 2 times 1, 7 over 2, 3.5 plus 3.5 is 7. And then we'll find this trapezoid, 5 plus 9 over 2 times the base, that'll be 14. Then we find this trapezoid, 9 plus 13. Uh, 22 over 2 is 11 plus 14, 25. We continue, and we're going to have 39.5 and 56. And we just plot those points, and we'll have the position graph. So at 0, we go to 2. 1 is 3.5. 2 is 7. 3 is 14. 4 is 25. And then we go to almost 40. 39.5, and then to 56. All right, and we'll stop there.